Aloha everyone, my name is Chelsea Anasio and I am the moderator for this semi-live DOT HAR construction training video session presented by Joy Zhang. Please use the chat during the presentation to ask any questions you may have and Joy will answer them while the video is playing. Joy is the environmental engineer at HDOT Harbors Division, Engineering Branch, Environmental Section. She is primarily responsible for developing and implementing comprehensive environmental compliance programs to satisfy the division's requirements for compliance with state and federal laws and department policies. Please help me welcome Joy.
All right, thank you so much for the introduction, Chelsea, and aloha everyone. Thank you so much for joining this training session focused on DOT Harbors Division construction and post-construction program. So either you are or will be working on a Harbors project or a project with a tenant at Harbors. And hopefully this fresh out of oven pre-recorded training video will provide you a glance review or some more in-depth guidance or some the perceptions or understandings of these two programs at Harbors. And also, this may also help you to understand Harbors' expectations. Well, without further ado, let's get started.
Thank you for
Chelsea, I don't hear any sound from my side.
You don't hear anything?
I don't hear anything. I can't hear the thank you part that it just cut off for some reason.
Let me try it again.
Thank you for participating in this training presentation on the State of Hawaii Department of Transportation, Harbors Division, Environmental Construction and Post-Construction Programs. It is important for all of us to ensure best management practice are properly implemented to minimize potential pollutants generated during construction and post-construction activities and prevent them from entering our state waters. Our goal as good stewards is to ensure that our coastal waters are clean for everyone to enjoy. Clean water is of vital importance for our own use as well as to the fishing and tourism industries. Further, it is our responsibility to protect our wildlife, including many only found here in Hawaii. Back in November of 2014, the Hawaii Department of Transportation entered into a second consent decree with the Department of Justice, United States Environmental Protection Agency, or EPA, and the Hawaii Department of Health due to alleged violations of the Clean Water Act at Honolulu Harbor and Kalaeloa Barbers Point Harbor. Under the consent decree, Harbors Division was required to implement various measures to improve the management of stormwater runoff. In doing so, Harbors created environmental policies and further enhanced their stormwater management program that is driven by the issued National Pollutant Discharge Elimination System (Npdes) permits. All projects under the Harbors Division jurisdiction must comply with the HDOT environmental policies. This includes the Director of Transportation's policy, which aims to make the HDOT a leader in environmental compliance, as well as the construction and post-construction programs, which are detailed in the Stormwater Management Plan, or SWAMP. Inspections are conducted to verify a project has adhered to BMP standards required per the SWAMP construction and post-construction program. These inspections will be discussed later in this presentation. Additionally, all construction sites must comply with applicable rules and regulations listed in this slide. The Clean Water Act was established in 1972 to create a basic structure for regulating pollutant discharges into waters of the United States. This act gave the EPA the authority to implement pollution control programs, making it unlawful to discharge any pollutants from point sources into navigable waters unless a permit is obtained. In Hawaii, the EPA has delegated authority to the Department of Health Clean Water Branch to administer the Npdes permit program, which is a requirement under the Clean Water Act, under the Code of Federal Regulations, Title 40, Part 122, and the Hawaii Administrative Rules, Chapters 1154 and 1155. HAR 1154 establishes the state water quality standards, which protect the water body for its determined use. It is important to remember that everyone must comply with HAR 1154, regardless if they need an Npdes permit or not. The Department of Health Clean Water Branch enforces HAR 1154 and HAR 1155 through Hawaii Revised Statutes, Chapter 342D, which authorizes DOH to impose penalties and fines against any person who discharges or otherwise causes or allows pollutants to enter state waters. The Department of Health Clean Water Branch issued 3 separate Npdes Notice of General Permit Coverage, or NGPC, permits to the Harbors Division for their Small Municipal Separate Storm Sewer Systems, or small MS4s, at Honolulu Harbor, Kalaeloa Barbers Point Harbor, and Kahului Harbor. These permits, along with the consent decree, are the primary driver for the harbor's stormwater management programs. This includes requiring oversight of construction and post-construction activities to ensure that stormwater runoff is properly managed and controlled to prevent pollutants from entering the small MS4 and adjacent harbor. The small MS4 permits requires the development, implementation, and enforcement of a stormwater management plan, or SWAMP, that complies with the 6 minimum control measures elements listed here in order to protect water quality and satisfy the appropriate requirements of the Clean Water Act. The updated version of the SWAMP is available online at the Harbor's Stormwater Management website. It includes procedures for complying with requirements from the consent decree and the small MS4 permits. Please make sure you are familiar with the SWAMP. Any comments or suggestions are appreciated. If deemed acceptable, changes will be applied to the next version of the SWAMP. Per the small MS4 permit and SWAMP, Harbors engineers, inspectors, and consultants involved in the construction and post-construction program require initial and annual refresher training related to their responsibilities. This training video serves to comply with the training requirement. In addition to this training, new site inspectors must participate in at least 3 construction site inspections with Harbors Engineering Branch Environmental Section as part of the on-the-job training to be considered qualified inspectors. This training will culminate in 3 specific compliance objectives as they relate to construction activities. The first is the Npdes program, which is regulated by the HDOH as previously discussed. All statewide harbors and harbor tenants' construction projects must comply with this program if they disturb 1 acre or more of total land area. This program also covers activities that disturb less than 1 acre of total land area that is part of a larger common plan of development or sale if the larger common plan will ultimately disturb 1 acre or more of total land area. It is the responsibility of the owners, design consultants, and construction contractors to ensure that permits are obtained and permit conditions are met. The second compliance objective is the Harbor's Construction Site Runoff Control Program, which all projects on the islands of Oahu and Maui under Harbor's jurisdiction, regardless of size, are required to comply. The third is the Harbor's Post-Construction Stormwater Management Program for new development and redevelopment. This is also applied to construction projects on the islands of Oahu and Maui under Harbor's jurisdiction that disturb 1 acre or more of land area when applicable. Therefore, a project may need to comply with 3 different environmental programs, in addition to other necessary permits. This presentation will cover the information necessary to comply with these 3 programs. Outreach to construction contractors and consultants is provided by Harbor's Environmental Section through coordination with the Harbor's project managers, project engineers, or construction engineer as needed. 3 types of informational exchange sessions may be utilized. As needed, which include pre-bid meetings, pre-construction meetings, and additional informational exchanges. Harbors defines construction activities as any activity that disturbs land, which includes but is not limited to clearing, grading, and excavation. The definition of construction activities also includes construction support activities, such as stockpiles, borrow areas, and staging sites. Land disturbance means the penetration, turning, moving of soil or the resurfacing of pavement with exposure to the base course. This may include construction roads, staging areas, stockpiles, grading, grubbing, and demolition. Please note that this does not include grass cutting or tree trimming. If you have any questions or comments, please contact the Harbor's Environmental Section. The contact numbers will be available at the end of this presentation. How exactly can construction activities potentially impact the environment? Impacts can occur when stormwater runoff carries pollutants from construction sites to nearby storm drains or waterways. Once stormwater has entered the storm drain system, it flows and discharges directly to the adjoining harbors. Thus, it is essential to control and manage potential sources of pollutants before they enter the storm drainage system. What exactly is an MS4? An MS4 is a system of conveyances that is designed or used for collecting or transporting stormwater and eventually discharges to surface waters. This may include storm drain inlets, manholes, canals, ditches, and outfalls. In Hawaii, anything that enters the MS4 eventually makes its way to our oceans. It's important to remember that an MS4 is not a combined sewer, which means any pollutants that enter the MS4 are discharged directly to our oceans without prior treatment. One potential source of pollutants is from what is called an illicit discharge. Illicit discharge is any non-storm water discharge that poses a risk to the environment. An easy way to remember this is that only rain should enter the storm drain. The pictures on this slide provide examples of illicit discharges that should be eliminated. There are many common pollutants that may be generated on a construction site. Materials and wastes that are stored on site, such as paints and trash, can be spilled or blown into the storm drain system. Wastewater from portable toilets could be released into the environment if not properly anchored and secured. Concrete washouts can significantly impact stormwater runoff by elevating the pH of the water if not properly contained and managed. Also, it is a common finding that vehicles and equipment often leak on the job site. The petroleum products from these releases are potential pollutants if not properly contained and cleaned up promptly. Other major contributors of potential pollutants on a construction site are stockpiles of aggregate material and exposed dirt because they can be very easily carried away by stormwater runoff if not stored properly. Erosion and sedimentation are common concerns at construction sites. Erosion results from the displacement of soil particles due to the wind or water runoff. Construction activities, such as grading, may increase erosion if left unprotected. Sedimentation is the movement and settling of suspended soil particles and is a result of erosion. Overall, if erosion can be controlled, then sedimentation will not be a concern. Studies have shown that in 1 year, between 35 and 45 tons of sediment per exposed acre can be discharged from an unstabilized construction site. In contrast, a stabilized site discharges only around 1 ton of sediment per acre per year. Sediment is one of the most common pollutants found in our waterways and can cause billions of dollars worth of damage annually. The following are some impacts that sediment may have on stormwater. Sediment may fill up storm drains and catch in basins designed to carry stormwater away from roadways, which may increase the potential for localized flooding. Excess nutrients from sediment increase algae growth. Sediment causes waters to become turbid, which prevents sunlight from reaching vegetation and coral. It also reduces oxygen levels, which may impact marine life. Sediment can clog fish gills, reducing resistance to disease, lower growth rates, and affect fish and egg larva development. Construction projects may have both short-term and long-term impacts on the environment. Specifically, construction projects often increase impervious areas, such as creating new paved parking lots and buildings. These impervious areas prevent stormwater from infiltrating into the ground and causes increased runoff volume. To mitigate these impacts, the Harbor's post-construction stormwater management program covers mechanisms and practices to be used at the site to manage and control discharges of potential pollutants and runoff volume after construction activities have been completed. The following slides will further discuss the Npdes program for construction activities. As previously discussed, the Npdes program is a part of the Federal Clean Water Act, and its overall goal is to regulate the discharge of pollutants from point sources to the receiving waters of the United States. Point source discharges may be from fueling, dewatering, construction, and even those from the storm drain system itself. The HDOH regulates this program locally and requires permits under Hawaii Administrative Rules Chapters 1155. Appendix C of the regulation provides information for construction compliance. Again, this is for projects that disturb 1 acre or more, or are part of a larger common plan of development or sale that disturbs 1 acre or more. The Npdes program for construction sites has several requirements. No later than 30 days prior to the start of construction, a Notice of Intent Form C, or NOIC, with a SWPPP must be submitted to DOH. After the Npdes permit has been issued by DOH, the contractor must notify HDOH no later than 7 calendar days before the start of construction activities. All personnel working on the site need to be trained on the best management practices, or BMPs, that will be used and retain all training records. This is to ensure that they know how to determine appropriate BMP measures and properly apply the measures. For example, proper application of a stabilized construction entrance or how to properly install the silt fence. BMPs should be installed prior to the start of construction and should match the BMPs described in the SWIP. For example, if the SWIP includes a silt fence along the perimeter of a site, the contractor cannot just install biosocks along the perimeter unless the SWIP is updated. Inspect and maintain all BMPs as needed. The SWIP is a living document and can be updated as needed. Upon acceptance by Harbor's designated project engineer, the changes must be logged and signed by the owner or its duly authorized representative. Finally, once construction has been completed and disturbed soil has been stabilized, the contractor will submit a notice of cessation to the HDOH. In accordance to HAR 1155 Appendix C, the notice of intent forms must be submitted via the HDOH e-permitting website. In compliance to Appendix C, the permittee must keep all necessary documentation on site and readily available for inspection by DOH inspectors, Harbor's inspectors, and other government agencies. This includes the Npdes permit, the SWIP, and the log of the changes to the SWIP. A monthly compliance report is required and should include information required in HAR 1155 Appendix C and the issued NGPC, any incidences of noncompliance and corrective actions. The monthly compliance report should be kept on site and be available if requested by an HDOH inspector. All of these documents must be signed by the owner or its duly authorized representative. HAR 1155 Appendix C outlines specific requirements to be included in the SWIP, which includes but is not limited to the following: the stormwater team including the names or titles of the team members. The stormwater team includes the parties responsible for inspections, corrective actions, training, SWIP updates, spill response, and any other aspect of stormwater compliance. A description of final stabilization practices that will be used, such as paving or seeding, as well as a description of post-construction BMPs. A site map that details the locations of potential pollutants, such as disturbed earth, stockpiles, and staging areas, as well as the locations of all BMP measures used on the site and in the drainage areas. Npads should be included in the SWIP. A new requirement is to indicate the boundary lines for the buffer area. The buffer areas are required when ground disturbing activities occur within 50 feet of state water. The HDOH provides several options for meeting this requirement. If there is sufficient space, the buffer can consist of a 50-foot barrier of undisturbed vegetation delineated with flags or other markings. However, with most harbors projects, there is usually not that much vegetated area available to be used as a buffer. The second option is to provide a smaller buffer with double sediment control spaced 5 feet apart. An example of this is to place 2 layers of sediment control along the boundary of the project site or state water. Please note that a silt fence with a berm holding down the bottom will be considered one sediment control, and an additional control will need to be added to achieve compliance. If there's no existing vegetation in the area, the third option is to provide double sediment control, spaced 5 feet apart, and the disturbed ground must be stabilized within 7 calendar days. If the project is considered as one of the exceptions, it will also need to be documented in the SWPPP if any of the above discussed scenarios are not feasible. This needs to be detailed in the SWIP and discussed with Harbors and the HDOH for other possible solutions. HAR 1155 Appendix C also details how frequently a contractor must conduct self-inspections of their site. First, you must determine whether stormwater from the site discharges into an impaired water body. If the water body is listed as impaired, such as at Honolulu Harbor, inspections must be performed once every 7 days and within 24 hours of any rain event of 0.25 inches or more over a 24-hour period. This means that the stormwater team is required to monitor and record daily rain gauge readings on site or daily monitor the nearest NOAA weather stations available online. If the site is discharging to a non-impaired water body, such as Kaleloa Barbers Point Harbor, inspections are required to be conducted either weekly or every 14 days, with additional inspections conducted within 24 hours of any rain event of 0.25 inches or more that occur within a 24-hour period. HAR 1155 also has specific requirements for correcting deficiencies or potential violations that could lead to a violation of water quality, such as the breach of a sediment control during a rain event. The deficiency is required to be corrected immediately, within the same day that it is observed. If the deficiency cannot be corrected immediately, the reasons for the delay must be documented and the anticipated time frame for the correction must be fully described. If significant repairs are required, this time frame can be extended to 7 days. Also, you will need to complete a corrective action report within 7 calendar days from the time of discovery, summarizing the identified deficiency and the corrective actions that were taken. The HDOH requires stabilization measures to be implemented immediately whenever earth-disturbing activities have stopped. Even if the work has only stopped temporarily for more than 14 calendar days, stabilization must commence. This could include paving the area, providing cover, or even seeding. Stabilization must be completed within 14 days after it has been initiated. But if the work is near an impaired water body, such as Honolulu Harbor, it must be completed within 7 calendar days. Any circumstance that prevents the project from meeting these deadlines should be documented. The timeframes for stabilization do not mean that the seed has to grow within 7 calendar days, but the steps should be taken to stabilize. These steps can include prepping the soil for vegetation, applying mulch, seeding, or even making arrangements for stabilization. To achieve final stabilization, which is required prior to terminating the Npdes permit, vegetation must provide 70% or more of the density that was previously there. For non-vegetative controls, paving needs to be completed. The following slides will discuss the Hdot Harbor's construction process. A typical construction project on Harbor's property will follow the process shown on this slide and will be discussed in further detail within this section. The project will be scoped by the project design engineers, and the anticipated environmental requirements will be identified. A pre-design meeting will be held to discuss the construction site design review checklist and permanent post-construction Bmp Plan checklist, if applicable for the project. Keep in mind that this meeting is optional for improvement projects owned and managed by Harbor's tenant. All permits and applicable Harbor's checklists should be completed by the designer. This includes a checklist for construction design and post-construction design, along with a post-construction Stormwater Mitigation Plan, or PSMP. Once these documents have been received by the Harbor's environmental section, it will be reviewed to ensure that all environmental requirements have been addressed. The consent decree lists specific requirements for the construction activities occurring around commercial harbors on the island of Oahu, which includes a review of project proposal, specifications, plans and drawings, construction submittals, Bmp plans, and the design review checklist by Harbor's respective sections. All Harbor's personnel assigned to review plans and to conduct inspections will receive specialized training. Prior to the start of construction activities, the project shall only disturb the areas as needed for the installation of the Bmp measures. After the Bmp measures have been installed, a Harbor qualified inspector will conduct an initial inspection of the Bmp measures, and only after any findings identified by the Harbor qualified inspector are corrected can construction activities commence in place. During construction, periodic Harbor's inspections will be conducted throughout the project. Additionally, the contractor is required to perform self-inspections. If any deficiency or potential violation is identified during the inspections, the Harbor's enforcement process will commence. After construction is completed, a final inspection will be conducted at the site to ensure that the project has been fully stabilized and all required post-construction BMPs are in place. Finally, post-construction BMPs will be maintained for the life of the device as recommended by the manufacturer or designer. More details will be discussed later on. The design review process may start with a pre-design meeting. During design review, designers may confer with engineering branch personnel in regard to required permits, Bmp requirements, and other matters. The designer must then complete a design that addresses environmental requirements when applicable. Documentation of that compliance must be provided to Harbor's environmental section for review. For non-exempt projects less than 1 acre, the designer must complete the design form for less than 1 acre. Additionally, for projects owned and managed by Harbor's tenant, if the design involves connecting to or discharging into the Harbor's drainage system, then a permit application to connect or discharge must be submitted to the Harbor's environmental section for review and acceptance. For sites that are 1 acre or larger, the construction design review checklist is required, as well as completed applications for Npdes permits, and again, Harbor's drainage connection or discharge permit for project owned and managed by Harbor's tenant if applicable. The submittal should also include the construction plans and SWIP. Harbor's has exempted certain types of projects from the program that have been shown to have minimal impacts on the environment. These categories include minor land disturbance activities, such as minor landscaping activities and interior improvements, post pole, sign, and fencing installation, utility repair work, parking lot, driveway, and other paved surface repairs, and other repair and maintenance activities with no or minor land disturbance. These types of projects are usually exempt from document review and Harbor's construction site runoff control Bmp inspections. This is the construction site design review checklist, which is available on the Harbor's website. It includes a general description of the project, project location, and size of disturbed area. It also includes a list of items that may need to be included in the Stormwater Pollution Prevention Plan, or SWIP. Designers simply need to check yes, no, or not applicable for each item and sign the form. The review will be considered accepted when the Harbor's environmental section has signed the form. Following the completion of design phase, the project will then go out for bid through public solicitation. Upon selection, issuance of an award letter and a notice to proceed or NTP letter, the construction contractor would then work on updating and finalizing the SWIP based upon their specific information and construction means and methods. The revised SWIP shall be submitted to the Harbor's project manager or project engineer, who will then provide the SWIP document to the Harbor's environmental section for review. Once accepted, the contractor can commence installation of Bmp measures, which must be inspected and deemed sufficient before any other construction activities are allowed to commence on the site. When conducting a Bmp plan review, reviewers will need to get a complete understanding of what is involved in the project. This could include the location and size of the project, where stormwater will flow, and potential pollutants. As previously discussed, potential pollutants on a construction site are typically associated with land disturbance, stockpiles, staging areas, and non-stormwater discharges. Reviewers should take a look at the schedule. To minimize the discharge of potential pollutants, it is best to conduct construction activities during the dry season, which is typically from April to September. Also, it is important for both the reviewer and the contractor to look for ways that can minimize the amount of disturbed area on a site. This could be accomplished through phasing the project so that smaller areas are disturbed and stabilized before moving to different areas of the project. The reviewer will also ensure that the SWIP is complete, in particular that the stormwater team has been named and responsibilities identified. Reviewers will also ensure that potential stormwater pollution has been addressed using the technology that is economically practicable and achievable in light of best industry practices. This basically ensures that the BMPs selected for the site will be effective. The plans should also include a method for final stabilization, such as hardscaping or landscaping. The reviewers will ensure that, for projects that are 1 acre or more, permanent BMPs with ongoing maintenance plans are included. Finally, the reviewer will ensure that the necessary permits have been applied for. In particular, projects that disturb 1 acre or more of land must obtain an Npdes permit for construction, and projects that will have dewatering operation, ending and discharging to adjacent state waters, must obtain an Npdes permit. There may also be permit requirements for working in water bodies from the United States Army Corps of Engineers. These permits should have been taken into consideration during the project's design phase. Designers must determine which permits are required, and reviewers verify. When applicable, projects owned and managed by Harbor's tenant may need to obtain a city and county building or grading permit. If a project disturbs 1 acre or more and requires an Npdes permit, the reviewer will ensure that the SWIP meets the requirements of Hawaii Administrative Rules 1155 Appendix C and the Harbor Stormwater Management Program. Typically, SWIP should be able to withstand a 2-year, 24-hour storm event without being damaged or needing to be removed for safety concerns. For more design details, please refer to City and County of Honolulu Stormwater Best Management Practice Manual for construction. BMPs are required to be implemented during construction activities in order to minimize impact to the environment by managing and controlling potential pollutants at their source. BMPs are a structural device or system or a procedural practice that is used to mitigate the discharge of potential stormwater pollutants. An example of a procedural practice includes sweeping, cleaning up a spill, or picking up trash, where a structural device used to mitigate potential stormwater pollutants may include a stabilized construction entrance or a storm drain inlet protection. It is important to remember that drain inlet protection should be your last line of defense for the MS4. Additional BMPs should be implemented to assist in preventing an illicit discharge from occurring. As required by the consent decree, Harbors has adopted the City and County of Honolulu BMP Manual for Construction, which provides information about the design details that should be followed. The BMPs listed here should be incorporated for all projects regardless of size when applicable. The consent decree also includes a list of BMPs to be included on projects that disturb 1 acre or more. These categories include erosion control BMPs, sediment control BMPs, additional control BMP measures such as wind erosion, ingress and egress, and advanced treatment systems, non-stormwater management BMPs, and waste management BMPs. Roadway paving and repair activities are specifically addressed in the consent decree. If your project involves these activities, ensure that each of these is included in the plans. There are a couple things to keep in mind from this list, such as restricting paving when it is raining and ensuring that all drain inlets are protected. Additionally, for paving operations, asphalt and sediment stockpiles should be covered when rain events are forecasted. Truckloads should also be covered when leaving the site to ensure that material will not discharge in the wind. In addition to consent decree requirements, reviewers will ensure that Npdes permit requirements have been addressed. Minimum measures include ensuring that a buffer or alternative is included if the site is within 50 feet of a state water. Perimeter controls must be implemented wherever stormwater may potentially discharge from the site. There must be BMPs in place to minimize the track-out of sediment onto off-site streets, other paved areas, and sidewalks. Stockpiles and dust must be properly controlled. Also, where possible, work on steep slopes and soil compaction should be minimized. Storm drain inlets should be protected. A specific plan should be made for contaminated soil that include placing it on an impermeable liner and covering it to minimize its contact with stormwater. Non-stormwater activities such as vehicle washing and concrete washout should be properly contained and managed. The plan should also include a written narrative of procedures for activities such as fueling, painting, and storage of materials. Here is an example of a plan review excerpt. It includes a stabilized construction entrance to prevent tracking. The drain inlets will have BMP protection. A dust barrier and silt fence are implemented along the site's perimeter. Also, there is a designated staging area with specific locations for construction waste, stockpiles, hazardous waste, and concrete washout. As such, the BMPs for this construction site appear sufficient. Next, we will discuss Stormwater Bmp Inspections, which will be conducted by Harbor's qualified inspectors, as well as expectations of a site while active construction is ongoing. The Harbor's Stormwater Management Program requires inspections of non-exempt construction sites. This is conducted to identify potential or active discharges of pollutants and ensure issues are corrected to stay in compliance and to avoid being fined by a regulatory agency. The initial inspection will be conducted by a qualified inspector after applicable site BMPs have been installed. Any deficiencies or potential violations noted during this inspection must be corrected before the contractor can commence any further construction activities. Once construction work has commenced, Harbors will conduct regular inspections for the duration of the project. These will occur every 2 weeks in the wet season, which is October through March, and every 2 months from April to September during the dry season. Deficiencies and potential violations noted during regular inspections may lead to enforcement actions if not promptly corrected. A copy of the inspection report will be provided to the contractor within 5 calendar days. A final inspection will occur once construction work is completed and the site is permanently stabilized. Remaining activities will have a minimal effect on stormwater runoff. These conditions will be described in the additional notes portion of the inspection report. At the same time, this inspection will serve to ensure that permanent BMPs are properly installed. Deficiencies and potential violations noted during the final inspection must be corrected prior to closing of the project. Final payment will be withheld until all corrective actions are completed. The initial, regular, and final inspections discussed in previous slides are a part of the Harbor's Stormwater Management Program and are conducted in addition to what may be required of the contractor. Contractors shall regularly inspect the condition of the worksite. If an Npdes permit has been issued for the site, then documented inspections must be done in accordance with your permit requirements. These contractor self-inspection records must be signed by the duly authorized representative, and the Harbor's inspectors will review the records during their inspections. Any changes to the BMPs must be documented. Harbor's inspectors will prepare for an inspection prior to arriving at a construction site by doing the following. 1. Review background data such as the plan review, permits, SWIP, Harbor's drainage map, past inspections, and any past enforcement. 2. Understand the site drainage pattern, including the receiving water and storm drain locations, as this is where potential illicit discharges could occur. 3. Identify all BMPs used on the site and coordinate with the contractor in regard to special safety or scheduling concerns. The following items are required in order to conduct inspections at a construction site. 1. The Harbor's construction inspection checklist should be used to document all inspections, and a notebook may be used for notes. Further discussion of the checklist will be addressed in the next few slides. In addition, a map that includes all storm drain connections should be used during the inspection to identify locations of drain inlets to be inspected. A TWIC badge is required to gain access to areas of the harbor and should be worn at all times during the inspection. Safety gear is important at construction sites, and the contractor may require additional precautions based on site activities. In general, inspectors should wear steel-toed boots, hard hats, safety glasses, and safety vests. A camera is also needed to document site conditions. A cell phone with the contractor's number. The construction inspection checklist is available in the Harbor's Construction Site Runoff Control Manual. After the inspection, the completed checklist will be emailed or otherwise provided to the Harbor's project manager or engineer, Harbor's environmental section, and the contractor. The inspector should also retain a copy. The first part of the checklist describes some common activities which may cause stormwater pollution. The inspector must indicate whether BMPs have been implemented to manage and control these potential pollutants and whether that BMP needs maintenance. For example, number 2 asks about storm drain inlet protection. If the inspector noted that storm drain inlets were fitted with filter fabric, then they would check yes under the column for control device. If that filter fabric had rips, then the inspector would check yes under the require maintenance column. The second page of the checklist includes information about the site's permanent BMPs and a place for additional notes about the site. In particular, the inspector should ensure that there are no illicit discharges to state waters and document that in Item C. When arriving on site, the inspector will check in with the contractor for safety reasons. A pre-inspection meeting will be conducted with the contractor and documentation items will be reviewed. The documents that should be on site include permits, employee training records, contractor self-inspection reports, and any associated corrective action reports, a monthly compliance report for sites with Npdes general coverage, and an updated SWIP. Following the pre-inspection meeting, the inspector should walk around the construction site to verify that BMPs in the SWIP match what is present in the field. The inspector should know whether these BMPs are sufficient in controlling pollutants. Particular heed should be paid to storm drains, canals, the harbor, and the site perimeter. This is also a good time to ask workers in the area some general questions about the BMPs. For example, if the team is inspecting the silt fence, the inspector may ask the construction worker how he installed the silt fence. The answer will inform the inspector about whether the worker has been trained properly. The following slides will discuss common findings identified during inspections and will present solutions for correction. Remember that correcting a finding may vary from site to site depending on the conditions, materials, and resources available. It is important for everyone to be aware of the site-specific BMPs and relevant requirements for continued maintenance. The updated Bmp plan must be available on site. The plan is the basis for how our regulator will evaluate the site and identifies which BMPs should be present on the site. The construction site pictured here did not have a trailer on site to store the SWIP. Therefore, the contractor installed a wooden shelf on the construction fence and placed the SWIP in it so that it was still available for workers and inspectors. Another common issue relates to construction site entrances. The tracking of sediment onto the adjacent public road is something that is easily visible both to inspectors and the public and can easily be carried into a nearby storm drain by stormwater runoff if not cleaned up promptly. Therefore, it is important that construction entrances have proper BMPs installed or implemented to remove the sediment from vehicle tires prior to exiting onto the adjoining street. As previously mentioned, a stabilized construction entrance prevents tracking. Specific details for stabilized construction entrances are included in the City and County of Honolulu Bmp Manual under TR1. In general, the entrance should be a minimum of 50 by 30 feet and covered with 3 to 6 inches diameter aggregate over geotextile fabric. Maintenance may need to be conducted regularly throughout the life of the project to remove accumulated sediment and keep the aggregate from settling. If tracking persists, additional BMPs can be implemented, such as regular street sweeping, washing vehicle tires as long as the wash water is properly contained on the site, and stabilizing the source of sediment. Silt fences can be used to control sediment throughout a construction site. However, they must be properly installed and maintained. If not well maintained, sediment may be carried off-site and result in an illicit discharge. Silt fence should be properly installed and maintained by setting the posts on the downstream side of the fence every 6 to 8 feet. The fabric should be stretched tight and the fence should be embedded in the ground approximately 6 inches to secure the bottom of the fence. The goal of a silt fence is to hold sediment-laden water while promoting sedimentation behind the fence. There are other products, such as filter fabric, that will let the runoff pass through. However, the silt fence is designed to keep that water and any associated pollutants on site. To aid in achieving this goal, proper installation should include properly joining segments of the silt fence. This can be accomplished either by twisting the 2 ends together or by overlapping them. Additionally, the ends of the silt fence should be placed in a J-hook pattern to prevent the stormwater from flowing around the fence. Maintenance will be required for accumulated sediment on the silt fence when it has reached 1/3 the height of the barrier. There are many new types of BMPs that have been developed by manufacturers. The one pictured here is called Hard Surface Guard and may be nailed into the pavement to keep potential pollutants on site. It does an effective job of filtering sediment and oil from the discharged runoff and can be reused on various jobs. Implemented BMPs can occasionally cause an unanticipated discharge of stormwater pollutants. In the instance pictured at the bottom of the slide, a tire wash area generated excess wastewater that could not be controlled by a berm. In this case, the wash area was moved, an additional aggregate was placed to increase the infiltration and stop the discharge. It is important to evaluate all implemented BMPs to determine whether they are effective at controlling potential pollutants and make changes where necessary. Additionally, it is important to ensure that perimeter berms are properly maintained. The pictures at the top show how compost berms can actually contribute pollutants if not maintained. Contractors should follow the City and County of Honolulu BMP Manual SE16 when using compost socks or berms on site. In particular, the berm must be filled and placed on level ground. The ends of the socks must overlap a minimum of 6 inches, and the end of the berm should be turned up the slope to aid in containing sediment. Accumulated sediment must be removed when it reaches a third the height of the berm. Additionally, berms are often ripped or damaged due to normal wear and tear. Contractors should be mindful of this when conducting self-inspections and replace damaged segments. Erosion control matting can be used on a site to stabilize disturbed soil until vegetation can be established. However, the matting must be installed properly. Geotextiles must have full contact with the ground surface in order to be truly effective. This may require the removal of larger rocks and obstructions and leveling off the ground. The mat must also be properly anchored. This involves trenching in the mat at least 6 inches at the top of the slope, overlapping sections of the mat by 2 to 3 inches, and stapling the mat every 3 feet. Filter fabric can be used to protect storm drain inlets from potential runoff pollutants. This should be used as a last line of defense after properly containing potential pollutants at the source. A common finding during inspections is that the inlet filter fabric has not been maintained. Contractors should be conducting frequent inspections to ensure that torn filter fabric is replaced and accumulated debris is removed. Saw cutting of concrete will generate fine materials or dust that are easily carried away in stormwater runoff. In the instance pictured here, construction workers were conducting saw cutting operations without a vacuum to collect the fine material for proper disposal. Slurry created during saw cutting must be vacuumed to remove it from the site. Slurry should be handled in a similar manner to concrete washout. The fine material should be properly disposed of and the dust controlled while conducting the operation. New concrete structures and slabs on a construction site always results in the need for washing equipment involved in the placement of the concrete. The improper management and handling of the waters used to wash this equipment can generate stormwater pollutants. This may occur if the containment device is not structurally sound or is too full. If an in-ground pit is used for the washout, it must be lined with one continuous sheet of plastic, as the overlaps between multiple sheets may result in discharge of the wastewater. Concrete residue is a fine material that can easily discharge into runoff, which will not only contain solids, but also change the pH of the receiving water. All concrete wash water must be properly contained. This can be accomplished by designating a container on site and removing the debris once the water has evaporated. Additionally, a cover may need to be added over the container when rain is forecasted to prevent the wastewater from overflowing. It is important to note that containment may only be filled up to 75% capacity before disposal is required. Temporary concrete washout facilities should be maintained to provide adequate holding capacity with a minimum freeboard of 4 inches for above-grade facilities and 12 inches for below-grade facilities. Spills and vehicle leaks are a common source of pollutants on a construction site. As shown in these photos, petroleum products are readily carried away in stormwater runoff. Vehicles and equipment should be regularly inspected for leaks. If a leak is observed, ensure that drip protection is promptly utilized. This could be a pan or even absorbent material with a barrier as pictured. In either case, it needs to be properly positioned. All construction workers should be trained on proper spill response. Spill kits must be kept on site and be properly stocked. Spill kits should include personal protective equipment, a plastic bag or other container for disposal, non-sparking tools such as a broom, and absorbent. The absorbent may be items such as berms, pads, or clay granules. Spills should be immediately reported to Harbor's project manager or project engineer, who will then notify Harbor's environmental section. Stockpiles of aggregate material must be properly contained if they are to be stored for more than 1 day. Additionally, stockpiles should be positioned away from waterways, such as drainage swales, storm drains, streams, or the ocean to prevent the material from being carried away from stormwater discharge. There are several ways to contain aggregate material stored on site. The stockpile could be covered, vegetated, or surrounded by a BMP device. These devices may include berms or silt fences to effectively contain the stockpiled material. The stockpile should not be higher than 15 feet to prevent excess generation of dust. Improper disposal of paint waste and painting equipment cleanout can introduce pollutants to the stormwater. Ensure that drips are contained by using tarps or another device when painting. Store paint within secondary containment. When painting operations are complete, ensure that equipment is cleaned properly. This includes scraping off the excess paint back into the paint can and washing the brush or other painting tools into a container such as a bucket. The bucket and remaining water-based paint can be allowed to dry, and the remaining debris should be disposed of as solid waste. Hazardous materials must be stored properly on-site. In particular, 55-gallon drums and larger of liquid materials require secondary containment. Containers should be inspected to ensure that they are in good condition and properly labeled. It is preferred that materials be stored in a covered area to prevent interaction with stormwater. However, if a container must be stored outdoors, keep it at an angle to reduce the ponding of water in the top of the container. This will minimize rusting and possible container breaches. Also, materials should be stored on pallets so they are not impacted by stormwater runoff. Shown on this slide are some common findings related to good housekeeping and proper waste management. Trash and debris throughout the site can be picked up by stormwater and carried to harbor waters. Make it a regular practice at your site to clean up debris at the end of each working day. Frequent sweeping of paved areas aids in removing sediment and debris. Solid waste containers should be covered and located 50 feet from waterways to prevent stormwater from impacting the wastes, and wastes should be removed from the site regularly. Contractors should separate wastes that may be hazardous from the other solid waste items and manage them properly. Here is an example of a construction site with several deficiencies. Inspectors should ensure that these are documented on the inspection checklist, and contractors should ensure that corrective actions are taken. In particular, there is a track out on the road with no apparent stabilized construction entrance. Furthermore, the silt fence has not been properly installed or maintained since the supporting posts are not in the downstream side, and it has partially collapsed. A stockpile on site has not been contained, and the concrete washout appears to have overflowed. Once the site inspection has been completed, all the findings should be verbally communicated to the contractor prior to leaving the site. This will allow the contractor to begin making corrections and establish goals for corrective action completion, even before receiving the formal inspection report. The inspector should clarify whether the contractor can email the photos of the corrections or if a reinspection is required. The inspector will present a written record of findings noted by completing the construction inspection checklist. Inspectors should also include photographs to support statements of finding. The checklist should only include a thorough explanation of site observations. If the contractor requests more information about how to address these findings, that may be provided verbally. In the event of a disagreement, inspectors must remain professional and provide a formal letter with documentation of the finding. Upon return to the office, the inspector will complete and sign the inspection checklist. The signature page should be scanned and compiled into a full report with the photos and a map of photograph locations if necessary. The report should be sent to Harbor's project manager or engineer, environmental section, and the contractor as deemed necessary. The inspector should then note in their calendar to ensure follow-up is completed. Throughout the construction process, enforcement actions can be implemented where necessary to ensure corrective actions are completed. Enforcement will only be conducted by a Harbor's qualified personnel who has internal enforcement authority. Enforcement will reference the Harbor's SWAMP, the construction contract, the Hawaii Revised Statutes, and the Hawaii Administrative Rules. When deficiencies have been identified and enforcement becomes necessary, an inspector will verbally communicate their findings to the contractor to allow the contractor to begin corrective actions immediately. If the contractor has not made the necessary corrective actions, escalating enforcement may be required. This may include a written warning via inspection report from PM or a formal letter from Harbor's engineering program manager. It could also include a notice of apparent violation, or NAV, from the Harbor's deputy director. If the written warning does not produce the necessary results, a stop work order may be issued by the Harbor's engineering program manager. Harbor's division may also consider withholding payment and assessing environmental liquidated damages when necessary. The last resort would be terminating the contract by the Director of Transportation. An extremely important part of this process is documentation. Inspectors may be asked to present their inspection reports or written warnings in order to determine the next level of enforcement needed. Once a regulatory agency, such as the HDOH, begins enforcement, there may be specific penalties associated with each violation that are compounded each day the violation occurred. The potential for penalties shown on this slide can be avoided if all parties working on construction projects follow the requirements in Harbor's construction program and apply the appropriate BMPs. The post-construction program is considered complementary to Harbor's construction site runoff control program. This section will discuss requirements while providing guidance for project-specific planning, selection, and design of post-construction BMPs to fulfill Harbor's Npdes permit requirements. Post-construction BMPs are vital because they will continue to address potential stormwater pollutants long after a construction project has been completed. For example, if a construction project is for a parking lot, a green parking BMP, such as porous pavers or a central grassy swale to provide filtration for runoff from paved areas, are considered permanent BMPs. They will reduce runoff quantity and will also assist with reduced pollutant loads such as oil leaks from parked vehicles. Please note that if you do include a post-construction BMP, there must be an operation and maintenance plan to ensure that it continues to function effectively for the life of the system. Post-construction BMPs must be considered and evaluated with projects disturbing land of 1 acre or more. There are some exceptions which include maintenance activities, re-roofing, interior work, utility work, and replacement of damaged pavement. Designers should submit the permanent post-construction BMP plan checklist and a post-construction stormwater mitigation plan, or PSMP, to the Harbor's environmental section for review. The permanent post-construction BMP plan checklist includes general information about the project and then asks to describe the type of pollutant control strategy selected. This could include low-impact development, source control, and/or treatment control. The Post-Construction Stormwater Mitigation Plan, or PSMP, begins by completing or locating an existing drainage study of the area. The designer then identifies sources of potential stormwater pollution that may be present after the site is constructed. For example, if the project was to include a fuel station, potential pollutants may include gasoline and diesel. Then the designer should present the drainage study, conditions of concerns, and a discussion on selected and applicable post-construction BMPs that will address those particular pollutants. Once the information is gathered, it should be compiled into a PSMP and presented for review. The maintenance requirements should also be reviewed to ensure that upkeep of BMPs can be conducted. This table provides more guidance about the types of pollutants that may be expected based on types of projects. For example, if an industrial development like a container yard were to be constructed, the post-construction BMP would involve removing sediment, oil and grease, and dissolved metal, if applicable. The types of post-construction BMPs are divided into 3 categories. Low-impact development must be considered and evaluated first, followed by source-controlled BMPs, and if either are not feasible, treatment-controlled BMPs must be evaluated. Low-impact development, or LID, involves retaining stormwater runoff on-site and viewing it as a resource rather than a waste. Some examples include preserving vegetated areas or collecting runoff from roofed areas to irrigate the vegetated areas. The goal of source control is to prevent potential pollutants from contacting stormwater. This may include covering a maintenance area. Treatment controls attempt to remove potential pollutants from the runoff. These include BMPs like a hydrodynamic separator. Designers could refer to the City and County of Honolulu's resources when developing the PSMP. In particular, the BMP manual, guide, and rules relating to storm drainage standards, which are all available online. As a rule of thumb, volume-based BMPs must capture 1 inch of stormwater and flow-based BMPs must capture and treat 0.4 inches of rainfall per hour. The following are some common permanent BMPs that may be included in a construction project. The simplest one is to preserve vegetation and natural areas that already exist on a site. This BMP is only practical in areas where there is existing vegetation and it should be marked off during construction. Bioswales meet the objective of both retaining stormwater on site and providing treatment. A bioswale consists of a channel where stormwater is directed and permitted to infiltrate into the ground, thereby reducing the quantity of stormwater discharge. Additionally, vegetation in these channels can be effective at removing pollutants that may be present in the discharge. Bioswales are ideally placed along streets and parking lots, where stormwater needs to be drained from a paved area and can also support vegetation growth. Another BMP designed to retain stormwater on site is permeable pavement, which is designed to perform the same function that normal pavement does, but also allows the stormwater to infiltrate faster into the ground. This BMP is often used in paved areas, such as driveways and parking lots. Hydrodynamic separators are designed to treat stormwater runoff as it leaves a site. As the discharge follows through the system, it allows for solids to settle out or float to the top and cleaner water to be discharged to the receiving water. These types of systems work well in areas where solid waste is expected, such as public areas and loading docks. Oil water separators are another option for stormwater treatment. Oil water separators are geared particularly towards the removal of petroleum hydrocarbon products. They are beneficial in areas where vehicle maintenance or fueling operations are expected to occur. Harbors has instituted its stormwater management program to protect our state's waters and to achieve compliance with environmental regulations. This is now a standard business practice for construction and should be followed by all persons involved. In particular, please remember that all projects must be reviewed prior to start. Projects that are of 1 acre or more must consider including a post-construction BMP. Inspections are required by the consent decree and Npdes permits and can be a great tool to identify problematic areas before they result in enforcement. Contractors should implement BMPs with the goals of keeping potential pollutants on site, preventing contamination of the receiving waters, and avoiding fines. All parties should be familiar with the City and County of Honolulu's BMP Manual for Construction, the Harbor's SWAMP, the consent decree requirements, and construction documents. If you have any questions, please contact the environmental section at the numbers shown. Also, please visit the Harbor's environmental website. To complete this training, please complete the training quiz and survey, and then email that document with your name to Ms. Joy Zhang at the address shown on this slide. Thank you for helping protect our environment. Here again, our shared message: protect our harbor waters.
All right, I think that's a training video we finished. Sorry for a little bit kind of extended long training video, but we're trying to cover as many points as possible. And I know there's a lot of information there. And thanks again for joining us on this training session. As I understand that today's presentation will be available for another 30 days on the same website. In addition, we'd like to thank the DOH for their continued guidance. Thanks to our leadership. Thanks to our sister agencies and the teams at Harbors for this collective efforts making this workshop possible. We'd like to continue to remind everyone to follow the proper social distancing protocols and wearing a face shield or face mask when you can to protect our loved ones, our colleagues, our communities during this pandemic. And yeah, we are open for any questions now if you have any. Unfortunately, we don't have a lot of minutes left, but we'll try our best.
So I know it's 4 o'clock already. If anyone does have any questions, please feel free to email Joy. But this now concludes our session and the 2020 Protect Our Water Conference. I want to thank everyone for joining us today. And we would also like to kindly ask that you fill out the post-conference questionnaire before you leave. And thank you again for attending.